In the last video, we talked about the architecture of the platform, about services and their interaction with each other. In this video, we will show how to work with some of the services using a demo case as an example. What is this case about? We have described in the system a technological process of a refinery. It takes the oil mixture and produces two products. One is shipped by rail, the other by road. The production line consists of several elements of technological equipment, such as separation column, furnace, tanks, etc. Let's start with the admin script first. The administrator and the user work with the system through a browser. Administrator's goal is to prepare the visualization tools for user work. During provisioning, the administrator performs the following steps: data collection setup, data storage setup, creating an object model structure, creating mimics, data mart setup, creating reports and dashboards. This is the navigation slide of the full presentation. This is the sequence of steps you will see during the scenario demo. Let's start by demonstrating the interface and functionality of the platform. First, we will demonstrate the work of the administrator and second the work of the user. The first step of the administrator's work is data collection setup. Data can be collected from various sources: OPC servers, controllers, devices, CSV files, etc. The tool for data collection is NiFi Collector or NiFi Processor Group. It is an ETL system that allows you to extract, transform, and load data into a databus in real time. The administrator must create a separate collector for each individual data source. Our scenario uses a simulator that emulates a real-time data stream. Through the interface, we can observe the status and parameter set for each collector. The parameter list is editable and depends on the collector type. Examples of such parameters in our simulator are the address of a Kafka topic, the scan class, the simulation algorithm, and so on. The second step of the administrator's work is time series database setup. This step is necessary because we are working with real-time data. The time series is a digital copy of the technical parameters. Technically, a time series is a collection of timestamps, values, and a set of attributes. In the interface, the attributes are divided into 4 parts. The most important ones, such as name, description, type. Interface attributes that define the connection with the collector. With the collector parameter, the minimum and maximum values of the parameter. Archive attributes that specify the compression settings on the server and the source. And define some functions for the processed time series. In addition, freely configurable attributes of the string type. From the current interface, the administrator can view the values of the time series in the form of a trend or a table. The third step of the administrator's work is the creation of an object model structure. The object model is a meta description of the production and actually represents a digital twin of the production. There are different types of object models. In our example, it is the equipment model. On the first level of the model, we see the factory, sales, and shipping objects. On the next level, the details of the upper objects, and on the lowest level, the final equipment units. Each object can have an unlimited number of properties. The property configuration stores the data source for this property. Such sources can be a time series, a constant, and SQL query, and a calculation. Table lookup and directory are a special case of SQL query. If the source of a property is a time series, the property returns the current value of the time series. If the source of a property is a constant, then this property returns the value of the constant. If SQL query then query response with update interval in minutes. If the source of a property is a formula, then the administrator can set up a calculation expression that takes the properties of model objects as arguments. This calculation can be an actual mathematical model of the physical process. First, we need to select the properties arguments. Second, we need to describe the calculation algorithm. Thirdly, we can choose the start type. Streaming provides for updating the calculation when an argument changes. By trigger provides for updating the calculation when a selected argument is changed. Periodic provides for updating the calculation according to a specified schedule. On demand provides calculation update only when needed. The device model is represented by a complete tree of objects and properties. The model provides easy navigation through the structure and allows reuse of created objects in the future. This approach allows for better scalability. The deeper goal of creating an object model is to have a single, consistent structure that contains references to all production data. In the Object Model interface, the administrator also manages equipment specifications. This is a function for checking objects for specific conditions. In our example, we check the level in the tank. If it rises above 90, the system generates an event that will be available to the user later in the event log. You will see later in the user scenario how this type of event is monitored by the user. The fourth step of the administrator's work is the creation of mimics. We will show you a very simple example where we just create a tank with a level sensor. Mimics work directly with time series. And we will go to the Mimic Editor application. When creating the mimic, the administrator creates the look of the mimic and adds active elements such as values, bars or trends and associates them with the properties of the object model. For example, I can add a cylinder like a tank and a bar like a sensor. Then I form link to property in the SC tank object in our equipment model. When I press this button, I can finally switch to operation mode and the data will flow into the mimic. Of course, creating a real mimic takes more time, but it's still a relatively simple process. The fifth step of the administrator's work is data mart setup. It is required because we need to create a relationship database. All reports and dashboards use relationship data as a data source because relational databases are better suited for queries over time intervals than over time series. For this purpose, let us go to the Universal Data Mart application. First, let us see the query configuration. Use the path in the object model. We have filtered all objects to one object. Second, we see Data Mart configuration. We can set the build depth, 1 hour in our example. Discretization, 1 minute in our example, and recovery period. Next, we select our query and get the result objects. Finally, we select properties such as aliases and can change the data types and some other attributes. After we check Enabled, the tool starts populating the relationship table named Column. The process of creating dashboards and reports is similar to the process of creating mimics and consists of setting up the appearance and data binding. With that completed the administrator script, let us now move on to the user script. Now we switch the role to the user. And the first mode is the continuous process control. The normal work of the user is continuous process control. To do this, user can open the Document Explorer of the application, where he can work with images, reports, and dashboards. To control the current situation, he uses a mimic diagram. Now the user can see the latest values of the properties. He can view information about each parameter and add any parameter to the trend. After that, the user can print the trend and export it as PDF or CSV. To get details, the user can switch to another mimic, such as PlanFact. Then, when he has obtained some data, he can return to the main mimic. Next mode of our scenario is data analysis. If the user wants to perform data analysis based on columns, he can also switch to the column dashboard. Here, the average and maximum temperatures of the upper and lower parts of the column are displayed, as well as the cumulative flow rates for the selected period. Next mode is reporting and reporting tools. Normally, reports are created at the end of a period of time, such as a day or a shift. During the creation process, the user must specify the report parameters and then click View Report. In this report, the user can see the number of measurements, as well as the maximum, minimum, and average value for each of them. The finished report can be exported to various formats, such as PDF. Usually, the reports are created automatically and sent to the users by email. This function is also available in the system, but we will show the manual creation for clarification. Next tools are manual data entry and event monitoring. Advanced users can directly enter a parameter value, for example in the training process or in an alarm situation. To do this, we need to open a data entry application where some parameters are available for editing and entering new values. In our example, we have added the tank level, which was previously used in the specification. I remind you that its value must be greater than 90 for the system to generate an event. Set the value to the current time. Let's open the event registration application. In the event registry, we can see historical events, including new events. Such events can be a trigger for email notifications or notifications from messengers. This concludes the user script and our demonstration.